Welcome back to PyraPOD. Today we did a special session with Richard and Yang, together with the owner of the greenhouse. Something like this. It's a greenhouse that is different from the passive solar Chinese greenhouse, but this is actually a symmetrical greenhouse. With a slope like this, and the width of this is roughly 8 meters. The height is at the center. That's about 3 meters, and the idea is to convert this type of greenhouse. By the way, there's a lot of this greenhouse in the places. My friend is growing seedlings. He growing plants for Chinese herb. To so that he sell the plants, right? And then people can buy the plant and then grow further, right? And to produce root and produce leaves, right? So anyway, this is that kind of application. And so he has 5 of these separated roughly by 1 meter in between, and then he like to convert these greenhouses into solar roof greenhouses. Okay, so we simply grab the profile from this, and and then we end up having this. So let's look from the side. And so as you can see from here, this line shows the original profile, but simply we wrap around this existing profile with a bigger envelope. That's the top is like an arc, right? And then the side vertical walls, right? And then the same thing on the two ends, So this shows the existing post, and this is the added one, right? Roughly half meter. And so simply the idea was we need to wrap the whole existing structure with a layer of cavity, right? That is roughly 5 meter in between, and then we fill the cavity with bubbles. But before you can fully understand the whole situation, I like to display Richard's patent. And this is Richard's patent, by the way, and probably a lot of people never look at his patent, directly. This is the second patent on the list. Okay, there's a page we list all the 6 patents, and this is the second on the list. As you can see, the patent was granted on January the 7th, 1986. Okay, this is the one. Showing Richard Nelson being the inventor. It's showing that he filed his patent, on October 18th, 1982. Okay, so this is a very detailed patent. So this shows that basically on each side of the roof, you can create a internal circulation. Okay, internal circulation. You see, it's separated by the vertical wall, and then create a space, right? And then at the one end of the space, you simply have a bubble generator. The bubble generator has a screen, right? Has a fan. Okay. The fan blow air in, right? There's a nozzle, spray the soap liquid, and cover the screen, and then the air blow through the screen, so create the bubbles. So this the arrow shows the bubble movement. Okay, so how the bubbles are created here, but then push, fill this cavity and then push around by the air, just fill until it reach to the fan, come back to the fan. That's complete the full cycle, and that complete the filling actually. So this is it, and same thing over here, right? So that shows the roof system, and this is also shows the roof system, but it's a partial roof. Okay, a window like this, but within the window there's partitions, right? Simply using this mechanism to create this flow. Okay, so yeah, that's what it is. This we already see, and this simply shows the liquid reservoir, right? Soap liquid reservoir, and how to bring up to the top and then create the spray, and then see this is nozzle, right? Two nozzles create the spray to cover the screen, right? And then the fan blow air in and then create the bubbles. Okay, so that's that. And this shows the simply a wall system. You can complete wrap around existing wall, and then and then create this pass. This shows that using one big bubble generator, you can simply fill the entire wall with bubbles. Okay, this is figure 6, and then here similarly you can convert, to make a floor. This is a floor system. That with this use simply one bubble generator, then just fill the entire floor with soap liquid bubbles. Okay, so and this shows that you can even create a section, okay, a small section, that to fill with bubbles. Okay, so there's many ways. This is a larger version, this is a smaller version. Yeah. Okay, so and this also shows that you can use industrial tube, right? To create the similar thing, right? So same thing. It just use a big tube to create a similar pattern. So that shows how the bubbles are created. And the note that this is the enclosed cavity. This is internal cycle. Okay, we're not borrowing air from outside. We simply borrowing draw air from one part and go through the screen, create the bubbles. So and then so in the process we move the air from open space into a smaller space. Okay, into the soap liquid bubbles. Okay, that's how it is. So by understanding that, then you come back, you can understand what we're doing here. Okay, so as I explained, we simply wrap the entire greenhouse with the double layer canopy. Then we place a total of 10 bubble generators, okay, at various locations. Let's focus on the central tunnel greenhouse. Okay, so here we put 2 bubble generators here, this end, and then same thing, 2 bubble generator here. Okay, and then 2 bubble generators here. So as you can see, the bubbles are produced from here and from here, fill this end first, right? and then once it fills this end, there's nowhere to go, so the bubble are squeezed, right, forcing to go this way, right? So basically, we're going to see bubbles are produced here, this end, and pushing by the air toward this end, okay? And then same thing over here, the bubbles are produced at this end and pushed toward this end. So and the same thing over here. So if we can imitate the whole thing, basically we see bubbles are created here and here and here and here, right? And here, and then just move pushed around, right? This thing going this way, and this goes this way, right? But the only difference is the ending, right? The end tunnels, right? Because in this end tunnels, we're not putting two bubble generator here, because then there's none over here, right? So in this way, because the flow is this, right? Flow will be something like this. This is kind of a smaller version, right? So kind of this. So we put a bubble generator at this end, okay? This end, we cannot see, but it's there's a one over there, so the bubble, creating this way, and this way, and going this way. So for this one, it's a kind of a, although the arrow shows this way, but actually along the edge, there's the top is going this way, but it's coming back this way. So anyway, so and same thing over here. So there's a bubble machine showing this arrow, see, pushing this way, but then another one is at this corner. You see here, we see it, and we see also the arrow. Okay, so so that's the idea. Okay, so so the bubbles are actually formed here at the bottom, and then this, and then we fill this, and then pushed over here, right? Take the whole 5 tunnel greenhouse as one entity, then we can make it happen, right? So that's it. Between the just get some details between the greenhouses, we use basically build a fence, okay, and on top of the fence we put 2 pipes like this, and then we need to explode. Then for the cover system, we simply create a rope edge along along the length, okay, and so that we can use this. This is actually just showing the hole, okay. We didn't show the rope, okay, showing the hole that the rope can go through, right? And then one at this end, one at the other end, and then we use it to tie onto the post and the horizontal bar, right? Horizontal pipe, yeah. So this way, that's how you fasten this corner, right, to the fence, right? And then in between simply is a gap, okay. In between is simply a gap, so that the water can simply flow right from the top and then flow down to the bottom, and then at the bottom you can collect the water, or you can simply let the water fall into the ground, right? So it depends, right? Depends whether you want to collect this the rainwater, right? If you do, you can very easily create a channel at the bottom and collect. So very simple. That's it. So hopefully you understand. You see, this is another way to apply the SolaRoof technology, and see how we can easily convert, easily to retrofit existing to the existing greenhouse, using the same profile, even the same fabric. If the fabric is relatively new, you don't need to change it, right? Because we simply use it to hold bubbles, right? And then we simply create a canopy. We use two frames, in this shape, and one at this end, one on the other end, and then we simply use that to hold the exterior cover, and then we blow air. Okay, so the operation is this: we turn on the fan to blow air. Okay. If the internal air is not enough, because it has to be slightly pressurized, right? Then we can borrow some external air and then create a slightly pressurized structure. Internal space, right? So that the exterior cover is expand, right, and separated from the internal layer. Okay, and then once it's fully separated, and then we can turn on the spray nozzle, create the spray, and then the fan will blow, simply blow through the screen and create bubbles. That's how it is. Yeah. Okay. This way we don't change the internal structure, and this way we simply build a fence in between the existing greenhouses, and then cover the whole thing, okay, with fabric. So yeah, very easy to do. So I'd like to present this. Hope you see that actually SolaRoof is indeed, is fully developed. One even Richard Nelson will apply for the patent, right? Long time ago, see the so detailed description of the patent. Probably a lot of people have never seen this probably, but now today we show this, and hope you like it, and hope you that this will help you understand how SolaRoof works, and remember that internal circulation of bubbles, right? Internal moving of air, right, from one location to another, and basically it's moving the air from the open space into a closed, a tiny bubble space. Okay, that's the whole idea. Okay, that's good. Okay, see you next time.